For the Visual Studio Code, we can create some example in here in order to what the holdout methods and the cross validation. Okay. In order to do that, we need to import the NumPy as MP. Okay. And import matplotlib pyplot as plt, and from learn the model selection parameters, import the train, test split, and k fold. These are the standard tools to what creating your training and test dataset. Okay? Genç adam, sus istersen de ben anlatayım istersen. Tamam. Okay. Firstly, we need to generate the random data by using the MP. Okay? And so we must randomize the whole data from some seed value. What's the seed value? Seed value means that it's the basic value or the basis value to generate the random data. For example, if you want to change this value, and so your algorithm in every time generates the random data. Before the data used are different from this one. Okay? And so also we can create the MP random rand function in here with the dimension of the 2, and we have the 200 elements in here with the 2 feature. Okay? And so we can also assign some data in here like this one, x0, the first assignment in here, and x whole data 1 is bigger than what to this data like this one. These 2 features are combined into one space, and if we have the bigger operation in here like this one, we can randomly assign to any data to 1. And so the as type function int. And so this is the standard conversion for this data into the integer type. Okay? And so integer type. So the holdout method can be accomplished by the simple train and test split function. Okay? And so we can assign this train and test split function with the x input value, y the output value. Okay? And the test size is a parameter in here like this one, 0.2, which means that the 20% for the test creation. The other term, 80%, is assigned to the training process. Okay? And also we can give the random state in here like this one, 42. It's an arbitrary number. You can use another number in order to create the random states. Okay? And we should take the variables in here like this one. X train, the first parameter, the return values of these things. X test is the second parameter. Y train is the third parameter, and the y test is the fourth parameters. And this function returns in order for firstly x train and x test, and y train and y test. Okay? This is simple holdout method. Okay? In the terminal page, we run this code and we will. Okay. Firstly, x train can be written like this one, and so we have the x train data like this one. This is standard list of with the 2 features, and the 80% of our data. Okay? And also we can write the other terms, but we don't need to. For the k fold, cross validation kf can be defined by this term, and k fault is imported from the scikit-learn model selection parameters like this one, and so we should split value. We should give this value. For example, in our example is the 3, and I can give the 5 split, and so the 4 train 1 test, 4 train 1 test in each iteration. Okay, and then shuffle is the default parameter in here like this one. It's true, and random state is equal to the 42, for example. Okay, you get it?
So is generating while correct, should we use brackets for each 0 and 1 summation?
Mr. Which line you are talking?
Line
8. A mi?
Yes.
8. Okay.
I guess their sum should be greater than 1, right?
Yes, but this is the standard operation. It's arbitrary function. May generate the y data. It's the y data is the random data, and so the x is the what's bigger than 1, and so I can assign the y. There's no meaning for this assignment in here. Okay?
Her zaman 0 olmayacak mı başta?
Hayır, olmayacak.
Toplamları birden büyük demediniz.
Hayır, toplamları birden büyük dedim şu anda.
İşte parantez için almadınız ya.
Ama parantez için almama gerek yok ki.
Önce bir öyle mi?
Evet. If you don't know the Python programming language, you can see my video or you can watch my video in my YouTube channel, because in this semester I teach the Python programming, and I will share the whole videos in my YouTube channel. Okay, but it's not important in here, because in real application you may have the y and x data. Okay, in the KF algorithm we have some plot function in here like this one, and so the fixed size is equal to 14 and 6. It's the standard combination in here, and PLT subplot 1 to 1, and PLT dot scatter function can be given in here. For example, x train, the whole data first feature, okay, and x train whole data the second feature can be given. Okay, and some other parameters y train can be assigned as a C map is a colorful representation of the R algorithm. CM and paired can be given, and the total label is assigned with the training data. Okay, these are the standard operation. We can use it or not, but I choose to use it. Okay, in here for the graphical representation, it's more understandable. Okay, and also we can give the scatter function in here like this one, the x test data 0. Okay, and the second feature is given in the whole data 0. Okay, and this term can be copied in here like this one, but with some different. Y test should be assigned in here paired, and these are called the test data, but you should also give the marker in here like this one, the x. Okay, because the test and this data should be different from each other. Okay, there is some error in here. Okay, and so title can be assigned with the hold out method. Okay, you can plot the legend in here like this one, and if we can write this code in here, and so I'm sorry, show must be given at this time, and this is the hold out method. Okay, and so training data is the circular point in here, test data is the what, the X data. Okay, training data is assigned these things, and the what, circular, the X is called the test data. Okay, but this is the holdout method, and so okay, cross validation methods can be given in the what, some specific for function and test index, because we have the 5 type of the data which is included in our study. Okay, so we split the 5 region, 5 data, and so key kf split x must be given because the k-fold is created in this term, and so kf is a variable coming from the what, the k-fold method, and so we can split the x data to what, to 5 split with a random order. We cannot split the total values in here, because if we have the 20% in here, we can assign the 5 region, but we don't know that. If you are using the 0.2 in here or 0.3, maybe your algorithm improves or not. We don't know that. But if you are using the more training data in here, like this one, and so you may reach the some stable ML application. But in your test data or ground truth proof cannot be given sufficient. Okay? And that's all what I'm saying in here. Because in the neural network application, especially for the ensemble learning, for the hyperparameter optimization should be done your ML application. In order to what? In order to find out the best option, your algorithm. Otherwise, we cannot say anything about the performance of the algorithm. If we can, and though we could be God, okay, in here. So this split is equal to the what, the x train and x test value is given in here, and so the x train index and x test index. Okay, in this for loop we can split the training to hold the data with the specific index of this term, okay, train index, and then we can reach the x data with specific index, and so we can assign the x train in here like this one, and so this term is assigned to the what, the x test. But in kf split provide us to what, the specific index which is randomly selected from the what, from your data. Okay, kf provide us. Okay, and also we can write it down like the y train and y test is here like this one, y train index and y test index. Okay, and so if we have this term in here like this one, the y, okay, okay, thank you. Okay, the subplot is 1, 2, 2, because we have the 1 row and 2 columns, and the second columns is included in here. Okay, and so scatter function can be used in here like this one, the x train 0, the whole elements of the 0, and x train the whole elements 1, and c is assigned to y train in here because it's the what, it's train data. we should indicate of the training data in here, like this one, and CMAP, the standard definition, LTCM paired. Okay, and label is assigned to the what, the fault. Okay, so label is assigned to what? No, I'm sorry. Label. Okay. So can update the scatter function in here, like this one, the x test, the whole data, comma 0, x test 1, and c is equal to gray. Okay, and the marker is equal to the x, because we should show the what this term. Okay, and then fault is equal 1 should be assigned in here, like this one. Don't remember the fault values in here. Okay. Okay. So this code should be given in here in each plot variable. Okay. And PLT title is equal to the what, k fault cross validation. Okay, and plot legend values of these things, and plot show must be run. Okay, I'm sorry, this must be a value in here. Okay. Okay. In each case, in the holdout methods we have this kind of information, but the fault 1, fault 2, fault 3, fault 4 and fault 5 is assigned to another variables with the same what, same picture. Okay, we can change the hold time in here as a list variable, but so you understand what I'm saying in here. Okay. Okay, so it's the basic example of the creation your data set. So right now we will continue with the regression process or the problem. Okay. Regression problem. Suppose that we have the data set like this one. For example, we have this data in here, the length and its price. Okay, for a given length we can assign any price in here, but without a function. Okay, this is a training data set or the total data set, and so we can assign the x is feature, price is output. Okay, and so we have some variables in here, the labeled variables, like this one, 100, 200, blah blah blah blah, and 300. Okay, and so each label is assigned with the specific x and y value, which is called to what? Ne diyorduk buna biz? Eğer label'sa ne diyorduk? Supervise diyorduk. Tamam mı? Arkadaşlar Türkçe cevap verebilirsiniz. Bu arada onu da söyleyeyim. Eğer İngilizce şey yapamıyorsunuz. And so we have this data set. And so if we have this notation, and then we can create the fx function or the sum model. can be learned from this data. And so, in the graphical representation, we may have this kind of information. For example, this y, price, and length. And so, this could be equal to the what? These terms. And so, we can easily set that we may choose the linear function to model this parameter, because the graphical representation shows us the best way to what? To select this proper function. Okay? And so, we have the problem in here, like this one. We should provide our model to the length. And so, we need to some specific function to model our parameters, which we call the linear model, or the some neuron model, or perceptron model. Okay? And so, we should generate the what? The price value. Okay? Or y. And so, how can we define this h value in the regression model? We may choose it. For example, I can choose the sum function in here, like this one. Y is equal to the a times x plus b, because it's the linear function notation. Because it's a linear, and we may have the some bias, but this model may be represented by this one. Okay? And so I can choose it. But I want to learn about these parameters. So we need to learning fast in here. From the what? From the data. Okay? If we have any data, and then we can learn from the data in here. But we need to understand that we should utilize the whole the training data set to what? To complete the learning fast. Okay? So, in summary, we should give the proposing the what? The model function in here. And later, we will call it the activation function. Okay? But in regression problem, we may not have the activation function, because in the graphical representation, we can choose any function in here to model it. Okay? So, in the second place, learning from data set should be accomplished. Okay? Because we may only have the total x and y relation, which is given in the what labeled data in here. Okay? And so, we should propose learning rule, because if we don't have the learning rule, and then this algorithm or this model cannot learn itself. Okay?
What do you mean by learning rule? What do you mean by learning rule?
So I can explain. I will explain later. Okay? And so we need to model learning rule. And how can we learn this data? By using the energy function, which I explained in the previous speak. Okay? And so, model selection. We have three phases in here, like this one. Firstly, we need to create the model selection phase in here. Okay? So, if the data set is distributed like the what, the x and y, something like that, and so we can write this down, this one. And so our model, or we propose the any model in here with the domination of the what, the h, x must be equal to unknown theta 0 plus theta 1 x, right? If we have the any second order system, or the second order square form system, and so we can add the what, the additional theta 2 times x square. Okay? We can choose it. So Normally, if we have the many data in here like this one, for example, if we have the 1, 2, 3, 4, 5, 6 data, the exact mathematical solution is given in the this form, root form, okay? X n is equal to 0. This is the exact representation of the mathematical formation for this data. Because if we have this function, and so each point is assigned to the exact solution by using this term. But this is not useful, because if we are using this formation, this mathematical formation, oversampling or the overfitting is creating in here. Because if we assign this term, and so this is the n order system in here like this one, and this could be maybe this one, okay? Because each point creates some higher notation or the higher peaks at each time. But our model is true for the red one, okay? So if we have this kind of data, and so we should remove the noises, or some data processing must be applied on this data in order to find out what's the best model on this situation, okay? So in the second place, for example, what we have the data like this one, and so we can select the some exponential function in order to imitate this form. For example, hx must be equal to the 1 minus exponential term x, okay? Minus theta 0 minus theta 1 x. This could be representation of the for this data, okay? You get it? You understand? Okay. So in the second place, we must define the cost function. In the previous lesson, we have talked about the cost function and its utilization of the optimization principle. Okay? So we model our system like this one, theta 0 and theta 1. But how to find out theta 0 and theta 1 in here? So if we are using, or if we use the cost function or definition of like this one, and if we minimize it, the error, and then we can reach the theta 0 and theta 1 value by driving the learning rule from this cost function, okay? Because in nature we should always seek the minimum principle, because it's dynamic. And so in the neural network application or the perceptron model or regression form, we should also looking for the best theta 0 and theta 1, and it's called the minimization points for our model, okay? And so this the mathematical notation is that mean theta 0 and theta 1 arguments in here like this one, the j are cost function, and so this gives us the model parameters, okay? Because if we minimize the terms, and so we can reach its nature or its dynamic, okay? And so firstly we need to define the error in here. Which error? We have the y data in training one minus h x in here, okay? And so we want to minimize these things, or if this term is equals or around to 0 in here, and so our model is the best one or the perfect one, right?
hx is a relative value. Hx is a relative value.
I don't understand.
Predicted value.
Predicted value. H.
Okay.
Okay. I don't know what that definition, but it's a model function. Yes.
You say that our model predicts the hx.
Yes. With the With the changing the theta 0 and theta 1. Okay. And so we can define the cost function in here like this one. For example, we must collect the whole terms in here, the endpoints is included in our data set, and so we should take the square form in here because the energy function must always be positive, because if you want to minimize it, and so the error may be negative, okay? And so negative values is always smaller than the positive one. For example, -1 is smaller than 1, but in reality the otherwise is true, okay? And so may choose the 1 divided 2. We add this term because we should take a derivative or reaching the first order system, because in the dynamic system we should always seek the what? The first order dynamics. For example, for the position we should seek the what? The velocity. For the velocity we should seek the what? The acceleration. In our cost function we should take a derivative of these terms in order to what? In order to get the learning rule. Okay? This is the analogy of the cost function, learning rule, and in the nature. Okay? Our learning rule like the Newton's law for the what? For our algorithms. Okay? So this is the what? 1 divided by 2. So and 1 and yt minus hx square. Okay, this is what? This is our cost function. Okay, so in the cost function we should use or not cost function. Make some rules in here. 1 divided by 2 may use or not. Why we add the 1 divided by 2? Because we have the square form. If we take a derivative and the 2 is coming from the head of this equation, and so 2 times 1 divided by 2 is equal to what? To 1. And so if I remove the 1 divided by 2, there is nothing change. Only the learning rule. Okay? So the cost function must be differentiable. What's the meaning of differentiable? Differentiated, yes. Yes. Because we should seek or search the first dynamics of the cost function. Because we want to learn how to learn from the data. Okay? So in the third place, we will turn into the what? The learning rule derivation. Okay? So suppose that we have the two feature vector in here, x1 and x2. These are the inputs, our model. And we have the theta 0 and theta 1. For the what? For the model representation. These are the nature characteristics of the what? Our perceptron or neurons. Okay? And so I can easily draw these 3D planes in here like this one. If I search the theta 0 and theta 1, and so one dimension is called the theta 0 and the other is indicated with what? The theta 1. And so this creates me a what? The sum j function, the cost function values. Okay? And so in each cost function we have the some minimum points like this one. For example, theta 0 and theta 1 are used for the what? 2.2 or the 2,5, and so in each representation creates this j function. But we should find out to what? This point, minimum point. If we reach this point, and so our model is learned or the model is completed. Okay? But how can we do that? we should firstly analyze this term, like this one. In order to represent this variable in here, like this one, and theta 0 and theta 1, I can show as a one dimension in here, because the differentiation must be showing in here, because it's not easy in the showing the third dimension. Okay, and so this is in the 2 dimension. We have this kind of information or the representation. Okay, and so we want to find out this point. Okay, for example, if we have the theta 0 2.2 which is in here, and 7.7 which is in here, but the optimum points 5 and 4, theta 0 and theta 1. Okay, so in a random place, for example, if we take the initial values in here, like this one, 2.2, and so our algorithm should go to what in this way. The both theta 0 and theta 1 should be increased by our algorithm. But how can we do that? We should use the tangent operation or the first derivative operation in here, because if we have this point, if we can take the derivative of this term, this is equal to dj d theta, and so this is always smaller than 0. And if we are starting this point, and so we have the differentiation in here like this one, and this term is always greater than 0. Okay, in each time of the optimal points we have the negative derivative, and the other term we have the positive derivative. Okay, and so at each iteration we can update whole the theta 0 value in here, like this one, theta 0 and theta 0. If we have the 2 value in here, but the theta 0 is here the 5, and so we add the sum derivation in here, like this one, and so this is the negative value, and then we have this information in here, dj divided by d theta 0, and so in each iteration I can add the negative values in here, and so in each iteration we can close at the theta 0 point. Okay, in the same rule, theta 1 is also the same like this one. At the left hand side it's true, but if we are choosing the 7 and 7, theta 0 and theta 1, and so this is greater than positive, and so if this is the positive, theta 0 at each iteration is smaller than the previous one. Okay, this is our learning rule. In each iteration we should seek the the minimum point. We are goes to the to minimum point. Okay, in each direction. If we have the 5 parameters, theta 1, theta 2, theta 3 or theta 5, and so we should take this procedure 5 times. Okay, but we have a problem in here, because if we have the 2 and 2 must go to the 5, but the derivative of this operator is equal to the 100 minus 100, and so this is the this is the, if I take this value, and so this value is equal to the the 102, and so we should scale this derivation, this formula, and so we can add the alpha value in here, and this alpha value is called the learning rate. Okay, learning rate means that these terms, so we can scale the derivation or the differentiation of the cost function by using the learning rates. Okay, so in algorithms we have the simple structure in here, like this one. For example, if we have the algorithm like this one, the while loop can be given with the sum j value is greater than epsilon. Epsilon, the hour notation or the hour condition. to be what satisfied in here. For example, this is equal to 0.00001. And so if the sum j, or the cost function, total cost function, is smaller than 1, and so the learning is completed. Okay? And so in each training data set, I1, 1, and n, and the training samples number, we should activate the theta 0 minus alpha times dj, theta 0, theta 1 minus alpha dj, theta 1. Okay? And so we should calculate the j function in here with the new theta, like this one, function of the theta 0 new and theta 1 new value in here after the updates, and then we can finalize the process. This is the basic structure of the regression process. Okay? So therefore we should choose the cost function in here, we should implement that, and so these learning rules are created or written on this for loop in here. Okay? But how can we take the derivative of these terms? For example, this is a partial derivative in here, like this one, dj, d, theta 0, and so the j function is equal to the 1 divided by 2 times y, theta 0 and theta 1 x. Okay? This is the basic representation of the cost function in here. If I take the derivative of these terms, we have the 2 is coming from the head and divide by times, and y, theta 0, theta 1 x is the internal part, with the same in the derivation rule in here, and then we take the derivative with respect to theta 0, y goes to 0, theta 1 times x goes to 0, and minus 1 should be given in here. Okay? This is the learning rule derivation. This is a simple operation of the partial derivation. And for the dj theta 1, which is equal to the 2 times 1 divided by y minus theta 0, theta 1 x times, so in this case we take the derivative of the theta 1, and so y goes to 0, theta 0 goes to 0. This term is equal to what? Minus x from this one. And so these two rules is implemented in in this notation. Okay? And then we can learn every regression problem by using these terms. Okay? So let's take a break, and then we will accomplish the Python implementation of this code by using the Keras library. Okay?